All right, number 4, you guys should have already gotten y-axis. Number 6 is numerical. 14a is yes. B is no. False statement, not a solution when you plugged it in. Had some fractions to deal with, but hopefully you guys didn't shy away from those. Number 22, the y-intercepts, there are 2 of them. You could have done 0 plus or minus 2, or you could have just done 0, 2, and 0, negative 2. That would have been fine also. But there were 2 of them. Number 42 and 43, I know it looks weird, but long story short, my solution manual, 42 and 43, was incorrect. Like, they didn't even have the right problems. There were some serious issues. So we're going to go look at the actual book itself in just a second. So just a warning, even on Calc Chat, that might have been messed up because usually they kind of like go together. Remember I said there were some typos right here at the beginning of chapter 1. So hang in there. We'll come back to 42 and 43, and maybe some of you guys saw like some things in Calc Chat where you're like, that doesn't match up. You might have been right on this one. There were a few that were off. Here's number 48, though. This one's right. Let me give you a second to check both your sketch, your 2 x-intercepts, and your 1 y-intercept. We're going to talk about that symmetry thing in just a second. So Gavin's gone, but it's because he actually switched into honors. Selma's in the back taking her quiz. And then we're good. Angie went to stats. Okay. And then Gavin transferred. In order to find those x-intercepts, guys, both of them, what would you have had to remember to do in the equation if you weren't looking at the graph? I know the graph, there are 2 points. It hits the x-axis. But in the equation, what should you have thought of doing when you set y equal to 0? When you set y equal to 0, how should you have solved this? Factor, 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 factor. Only with factoring will you see both answers. If you're not looking at the graph, just the equation, you would have had to factor. But wasn't it easier than some of the factoring we did yesterday? Good. Okay, let's get to the next one. 51. They did a table. I don't remember if the directions told you to or not. You guys can check really quickly at the directions you summarized, whether or not they asked you to make that table, but that is a valid way of trying to make that graph. It's a bit more complicated than parabolas and lines, etc. There's only one x-intercept. Wait a minute, where's the y-intercept? Why is it none? Because if you plug in the 0, it's a square root, not just a square root, but a square root of a negative. Yeah, that's imaginary, complex, no y-intercept, and the graph shows that if you graph in your calculator to double check. Let's go back to the parabola real fast. Why is the answer no symmetry? I totally see symmetry, don't you?
It's not on x-axis.
It's not x-axis, it's not y-axis, it's not origin. Good. It's not centered where it would need to be to have that y-axis symmetry. It does have symmetry, but its symmetry is around some random, not random to it, but random to the whole Cartesian plane. A random place, x equals -1. That's the fold line. So it does have its own symmetry, but it doesn't have x, y origin, just in case you guys were wondering about that. But this one, it just has no symmetry whatsoever, not even a kind that we can describe to itself. 55. It was written a little bit weird. You might have been a little confused about the graph, because if you tried to use your graphing calculator, you would have had to get y by itself. I'm going to show that really quickly, just how you could have checked with your calculator. Not that you should have or needed to, but you could have, as you guys finish checking him. If you did try to graph them on your graphing calculator, hopefully you realize you would have had to get y by itself, but the common mistake would have been y equals the square root of x plus 1. Y is only half right, plus or minus. Whenever you have to square root a square, there's a value property that, but what that ends up resulting in is needing to do a plus or minus square root for that y value. And so that would give you the top part for y1, the bottom part for y2, if you had checked. But if you guys found your intercepts, if you figured out that with square rooting you need to do plus or minus 1, maybe you would have forgot the plus or minus there also. You would have seen these 2 points, and maybe you would have remembered from Algebra 2 that any squared is a parabola, but when the y is squared, it's not up, down. Instead, it's right, left. It's horizontally oriented. Good. But if you had forgotten the plus or minus, you would have gotten a little bit mixed up. Hopefully x-axis symmetry worked out pretty well if you were testing like we did yesterday. 65, right? I think it was just like a, hey, can you get the picture in your calculator and find the intercepts using the calculator? Maybe some of you would have tried to do the 0 feature. Did anybody realize the 0 feature sometimes doesn't work? And this is an example. Yeah. So pause for just 1 second, Joe. You totally got it. The rest of you guys, what are the questions that the calculator asks you for the 0 function? Okay, hold on. Thank you. But didn't I say be quiet for a second, Joe? Thank you. But you got it. So hold on, pause. I want to hear how everybody else is doing. So what are the questions that the calculator gives us for zeros? You hit the 0. Left bound, question mark, right? You have to go to the left, go to the east, kind of, west. And then right bound. And then it says, the third question, it says, guess. So if you properly do the left bound, right, why was this a problem? Joe said it a second ago, but can you guys verbalize it yourselves? Why is that bad?
It cuts off, like, at the axis.
What in the function makes it cut off? What was so special up here that restricted the, good. Under the square root, I can't have what types of numbers? I can't have negative numbers. So therefore, -7, -8, -9, if I plug in, ooh, imaginary, imaginary, imaginary. There's something called a domain restriction, a domain problem. So only part of the x values work. I mean, everything greater than or equal to -6 works. But there was no left bound. So therefore, that was something where you had to maybe zoom in or trace it, or just look at the function. Maybe you could have figured out by, wait a minute, we didn't even have to use the graph. We could have. Couldn't we have set the, forget that doesn't work anymore. Sorry. Couldn't we have set the factors equal to 0? When I said this guy equal to 0, x equals 0. Perfect. If I said this guy equal to 0, wouldn't I have had to square both sides? 0 squared is just 0. X plus 6 equals 0. So you could have found -6, hopefully not with too much difficulty, just algebraically. But if you're trying to use the graph, the 0 feature wouldn't work because it assumes every 0 goes through the graph. You can go before or after, but it's not always true. Okay. Thank you, Joe. You were doing well. I just needed to hear everybody else for a little bit, okay? Number 71 and 74, let me give you a second. They were both circles. 71 was hopefully super straightforward. Just plug in. 74, I had to work for it. Just a little bit. Because we plugged that center in. We plugged that center in. But this, what did you have to use in order to find it? Distance formula, which has a square root. The distance formula, which has a square root. Distance formula between the center and some random point on the outside. Does that make sense? And if you were really cool, you could have just said Pythagorean theorem, because you could have graphed them both and made a triangle. Is that the end, or is there a little bit more? Oh, there's a little bit more. I think it goes down to like 85 or something, right? Oh my goodness. So sorry. 75, 79. Wait, why do I have those? Those are odds. I think it was something where, at least on Calc Chat, they were doing different problems. It got out of order. I think they had like an old assignment from an old edition where the problems were different. So just in case you guys needed to check these, I think the back of the book was good, but Calc Chat was off. So just in case, I put it up here for you guys to check. But you're right, the next even is 82, right? Okay. Anybody still checking? I don't want to cut you off. Okay, 82. Just not going to touch it. Center, radius. Can you guys help me out with the directions on this one? Were you going from the equation to the graph? Is that what you were doing? Did they give you that to begin with? Okay. So that's why this one was a little weird. They were asking you like, hey, we already did all the work. Now figure out what's going on. Oh, we have the x minus h positive 2. Y minus, the only way to get a positive from a minus is a negative. And then why they go 16/9 to 4/3?
1 squared.
R is squared. And remember, with you square with the numerator and denominator. Then just throw in your center and go 1 1/3, approximately 1 1/3, 1 1/3 all over the place. Okay, I know 85 was weird. We're going to totally go over that. I have the question actually copy and pasted in the homework questions just because I know it's a thing. We'll get there. But first of all, any evens or odds that you guys want to go over from the beginning of homework? Yeah? 29? Anything earlier than 29? Okay, let's start with 29 then. So 29, you're supposed to be doing this. Work on keeping those on silent, but I understand. Find the x and y of the equation. On number 29, I suppose you could have tried to get the graph, but technically they were asking you to solve this by hand, so I think it'd be a lot easier just to do our tricks of plugging in x is 0, y is 0, rather than trying to get a graph, because that's just not pretty. It's a cubic. Blah. Anyway, so if we were to try our tricks, hopefully just keeping everything straight. I'm just going to cut it off here because we know the directions. Finding the x-intercept and the y-intercept. 29, right?
Yeah.
Cool. All right. Beta quiz time. If it was a pop quiz, could you get 100? If you want to find an x-intercept, what do you set equal to 0?
Y.
Good. So y equal to 0. Get back to that in a second because he's the hard one. Maybe some of you are like, let's do the hard one first. Go for it. I'll come back to it. Y-intercept. Set who equal to 0?
X.
Why is he the easy one? What's 2 times 0 cubed minus 4 times 0 squared?
0.
Got it. So I have the point 0, 0, because y equals 0. Come back. What do you need to remember every time? Good. What's in common?
2x.
Good. 2x squared makes it a little bit easier. What do we do when we have factors equal to 0? But not just x minus 2, technically. Can't we group this guy into one factor and that guy into the other?
Yeah.
So then we can go ahead and set that guy equal to 0 and that guy equal to 0. Some of you can mental math that and say 0 and 2. Some of you maybe off to the side might need to go ahead and set it up. And even if you have to go step by step, it's not bad, but what's the plus or minus square root of 0? 0. Yeah, there's not really two answer choices for that. Square root of 0, negative square root of 0, it's all just 0. So there's our 1, and then most of you can probably see. Are we cool? Got it. Okay. Anything else besides 29 before 85? Going once? Yeah. 75 asked, or I should say, gave different clues than even like the examples that we did in class. So it was a little bit more out there. It was talking about a diameter. Now help me out from geometry, kiddos. A diameter? I'm getting the directions just so we can see it. What's the diameter of a circle? Yeah, across, all the way across, right? Radius is from the center out to the edge to whatever solution point. It's always the same. But diameter is all the way across. So if in number 75 they give us these 2 points, if you want to be snazzy, I mean, you can totally visualize this. So we have 8 around there, 6 around there. Okay, how big is our circle? Pretty big, right? Because we would cut that in half and that would be our radius. Wait, cut that in half and know our radius. How do we get halfway in between 2 points? Section 1.1. Midpoint. So couldn't we find the center just by doing the midpoint? And maybe some of you are like, wait a minute, if you go over 6 and up 8, then maybe the midpoint would be. But just to make sure, you could go ahead and, thank you for the mental math, I'm showing how it works the long way. Yes, it would just be 3, 4. You think that a line, the ratios are going to be the same. So over 6, up 8, you could go over 3 and up 4. You would cut the horizontal in half and the vertical in half. Right? So now that you have the point 3, 4, you have your h, you have your k, but what else do we need for our circle formula? Radius. But now that we have this point, we can maybe just find the distance, either between 0, 0 and or 6, 8 and. I think 0, 0 would be a lot easier, right? And if you want to be super cool and say, wait a minute, haha, over 3, up 4, Pythagorean theorem, this is a 3, 4, what triangle? So I'm cheating a little bit, but yeah, maybe that's cheating, using my resources. But 3, 4, 5, so my radius is 5. Once you have that, plugging and chugging should be easy. So the H, A, R, done. Anything else up until 85? Okay, good. Why am I going to do 85? How many of you guys or slow down somewhere on 85? Okay. Now, I have it right here, but I have it here as well for us. Because of that new setting Mrs. Christensen put on, it's not her fault. She just didn't realize how much I use it. Let me just go here and take a picture. It'll be easier. Okay. Let's talk about something real fast. Just as far as my 4, especially 2 and 3, which has a lot to do with homework. And even doing the little things with integrity and working hard and being willing to make mistakes so you can grow before a test, not waiting until the test to be real with me. It's always dangerous. Like, I got it, I failed. Super sad. Sometimes it happens, but usually there's been a gap all along the way. Okay. Where did number 5 occur in your homework? As far as like the placement and the numbering of the problems. At the very end. Number 85 happened at the very end of homework, right? Okay, so let's think about this. In pre-cal homework, where do you think some of the most work-intensive problems might usually occur? What's the dilemma about the end of homework? You're done, right? You're like, I've been working on this thing, hopefully. I've been working like with my notes. I've been sometimes having to access my section, like the examples. I've been going to Calc Chat, maybe grading along the way. It's a little dangerous, but I can realize it can be helpful sometimes. What do you think is going to be a temptation this year if we tend to try to go over as many homework questions as possible, which isn't always possible to do all of them. But what's going to be a temptation whenever you get towards the end of homework and you're tired and a word problem occurs? Put a question mark and be like, oh, I got stuck on it. There were words. She'll understand. What's the dilemma if you just leave all the word problems always blank? A, you don't try, and B, you don't learn how to struggle through reading it and trying to get as much as you can out of it, and then you get to a test, a word problem, and you're like, well, maybe I should have done those on my own at some point. And you're putting the expectation on me the next day in class to totally walk you through every single word problem and not get really far behind it. And that's unrealistic. So, as you're submitting your pictures, I do not expect perfection in homework, right? And on the weekends, I'm going to go ahead. That's typically going to be my catch-up time, probably Friday afternoons, evenings, depending on how I'm spending them. But trying to go through your guys' like classroom pictures, see how you attempted homework for the week and get you grades so your parents can see before the next week how the attempts were on the homeworks that were due, etc. But as I look through your homework, am I looking for you to be like, perfect, all these problems, gorgeous? No. Because if you get tired at the end of homework, and if you're like, I have to do this perfectly, what else are you going to be tempted to do? It's an odd. Calc Chat, there's stuff. Just won't even think about it. I'll just get it done. I'm done. I don't want perfection. I don't want you to go copy Calc Chat. That doesn't help you any better than you just skipping it. Every now and then, maybe one student could probably learn through that. But most of you know. And it ruins your integrity. So, just to let you know, I'll be looking for ones copied from Calc Chat, because Calc Chat has a very certain way of doing it. I'll be looking for that, but I'll also be looking for just blank ones. What are you supposed to do when you get to a word problem? Read it, summarize the directions, summarize what you're supposed to do for all the different parts, if there are different parts, right? So for instance, this one, I mean, letter A, come on guys, letter A was just to draw, yeah, like, okay, be blank, draw, you guys can do. Your directions, what do? You have an NFL field, right? Okay, including the end zones. If you want to put that, fine. If not, you can just draw little end zones. Be like, yay. But it also says length of x. Isn't, like, by drawing the rectangle, aren't you basically summarizing the directions, besides the fact it's an NFL field? But there is one super important clue that if you didn't write down, there's just no hope. What's the important clue from the directions? Equals. Now, yeah, you could do the mixed number. That's really helpful in saying 346 and a little bit. But as far as doing math, it's a lot easier to use the 1040 over 3, personally speaking. Okay. Why did I leave an awkward big space? Because I took geometry. Well, and I remember most of geometry. I shouldn't say that. I don't like the whole, like, lines that cut through and come to a point, the inscribed lines and the angle. And anyway, I don't like that stuff. I always review it if I'm tutoring. I just look at the section real fast. But anyway, a lot of geometry I remember. And if I see perimeter and I know rectangle, I'm thinking, are you thinking what I'm thinking? What? What formula? Yeah, what's the perimeter formula for a rectangle? Not length times width, that's area, that's the inside. But 2L plus 2W, or 2X in this case, plus 2Y. Sometimes in math, it's helpful not just to write the words, but to think about what they mean. Perimeter, rectangle, oh, that's a thing. Like, maybe I should know that. Now, there are some geometry things in the back of the book. Mostly three-dimensional solids, because those are the things you mostly forget, like base times height, 2 length plus 2 width. Hopefully things you remember a little bit better. But some of you might have had to go back and remember, but they're not always going to give you everything, something that you should know from before. Does that make sense? So sometimes you kind of have to about it. But if you didn't write this down, there's no way you could have done B. Or if you didn't think about this at some point in the whole problem, you were stuck. Because after drawing the rectangle, labeling X, labeling Y, writing down the clue given in the directions for the NFL field, now you can go ahead and start approaching B, and B says to do what? Show this is true and that is true. Well, I don't have any equations. Yes, you do. Here's your equation. You just had to come up with it. Guys, who's alone?
Why?
We did this with slope-intercept form, right? Maybe we haven't. Sorry, it's section 1.3. But we've gotten y by itself at some point in your math careers, probably lots of times. Where's y? Can you get y by itself? What's going to happen when you get y by itself? It's going to be that. Because when you get y by itself, do you guys realize that we would subtract the 2x? Are we good? Now what would you do? Divide by 2. Do you realize dividing by 2 is going to get nasty real quick? So what's a better way of dividing by 2? Multiplying by?
1 over 2.
I was thinking by 1/2. You could multiply everything by 3. That's valid because you'll get rid of that fraction. But most people are focused here thinking y by itself. So if you multiply it by 1/2, won't those two reduce? And what you do to one side? So now I get y by itself. That's just going to be an x. This is going to be 1040 over 6, or aren't those both even? So I can reduce. 2 goes into 10 5 times, 2 times, 0 times, 520. If you didn't get that, you just didn't think about perimeter of a rectangle is 2x plus 2. You told me the area formula for a rectangle on accident when I asked for perimeter. What's the area formula for a rectangle?
X times y.
Base times height, or in this case, x times y. Well, how on earth am I supposed to... Oh, what'd they do?
Replace it.
Substitution. They said, oh, instead of y, plug in what y is. Oh, And why did they do all that work, which was kind of weird and kind of tedious? Because step C says, and ultimately step D says, the point is we want a maximum area possible. Maximum area, because depending on whether it's wider or narrower, you're going to have different like playing area. So maybe they're trying to say like, oh, hey, if that's what needs to happen, what's the max field that you could have? Well, to find the max, let's just say it takes calculus, so it's kind of hard, which is why we're going to use our calculator. When we use our calculator, you can't really put something in the y equals if there's not just. So we couldn't have put a and x and y into y equals. It doesn't work. But we can put in. I shouldn't close my calculator. Sorry, guys. But we can put in a function with just x's. We couldn't have put this in. It's impossible. But we can put this in. The only awkward thing is going to be when you go putting this in your calculator, can you make an a equals in your y equals menu? You guys ever tried to change the y? It doesn't work. So we're going to have to make a equal to y1. We're going to have to put the a in the y1 spot. But we're just going to put this in. And once we put this in, they're even telling you what to do. If you get a nice pretty window where you see your downward facing parabola, you'll have to play with your window. Guess what every downward facing parabola is going to have?
Maximum.
And what are you looking for in part B? Nope, D, sorry. You're just going to find the maximum. And then you're done. Does that kind of make sense? It's on CalcChat. I'll let you guys go ahead and check it out as to whether, wait, hold on. When are you expected to have the homework like polished, finished, corrected? Like, okay, I think I kind of got my questions answered by? Technically the test. Now, is it smart to leave all your questions till the night before the test? No. But at least in class, we helped you figure out what you did get, what you didn't get, and what you didn't get, hopefully at least have a direction to go. Are we tracking? Cool. All right, guys, thanks for putting up with a lot of, we're still kind of going through logistics. But hopefully that gives you at least a direction. And if you can't up to make it, come on in and let's look at number 85 in more detail. Lauren. Yes, you may. Section 1.3. Oh my goodness, we only have like 12 minutes of class left. 14, 13. How on earth will we cover a section in that amount of time? Jordan, give me 1 sec. Let me finish my thought. Otherwise, it'll just be weird and random. We have 1, 2, done. Go team, we got this. Jordan, go ahead. I might have. If I see graphing calculators, I kind of hide them in the back so that people don't steal them. What's it look like? Is it one of the gray ones? Jordan, I got you. Come grab it. If you ever lose your graphing calculator, check my room because you had class in my room. Check the office. Then maybe frantically go ask all the different teachers, hoping someone gave it to a math teacher, not knowing what class it was from. And then give it a couple days just in case someone has like a crisis of conscience and they're like, oh, I shouldn't have stolen that. And then you might have to go looking for another one. Oh dear, I haven't seen that one. I'm sorry. If there's anything like pencils or pens, I usually just put it up here on the tray. That way you guys, or like textbooks, that way you guys can see it when you come in. But calculators I keep back there because those things go missing like none other. All right, 1.3, here we go. I blame it on middle school or ninth graders just because they're like, ooh, I'm going to have to, or ooh, it's nice and pretty. But realistically, it's probably high schoolers too, sadly. Maybe someone stole theirs and they're like, well, fine, I'll just, I don't know. But it's a sad, hard truth. All right, here we go, section 1.3. Why is it so short? I don't know, you guys tell me, look at the title. Lines. Lines. I'm going to put 3 different titles of equations of lines. 3 different titles of equations of lines. I'm going to go ahead and put slope-intercept. I'm going to put point slope. I made the honors kids come up with their own names, but you guys will help out. Let's just write out standard. So we have slope-intercept form, we have point-slope form, and we have standard form. What equations do you remember out of those 3? Now pause, don't tell me. Instead, vote. Vote for the one that you're most familiar with. Does that make sense? Just by a raise of hand, vote for the one that you're most familiar with. How many of you guys are most familiar with standard form? How about point-slope form? Ooh, nice. How about slope-intercept form? Wow, not at all what I expected. Maybe we should write the forms down first. I'm not entirely sure that you have the right ones in mind. Slope-intercept form. It's a form that has a slope and an intercept. Not just any intercept. A y-intercept. That form is y equals?
mx plus b.
Okay. Point-slope form. It's a form that has a point and any arbitrary random point as well. Not the slope I shouldn't say that. Not the y-intercept specifically, but any point with a slope. This one is y minus equals? Careful, m times x minus x1. And standard form is the awkward one that doesn't have an m in it at all. And the x's and y's are all on one side. Good, and it's ax plus by is c. Let's revote. How many guys are most familiar with standard form? How about point-slope form? How about slope-intercept form? There we go. That's what I expected. That's the guy that we all revert to, almost. But here's the sad thing. Every one of you but Matthew. This is the one that is most useful, most helpful, and most important in calculus. Why? Remember the whole, you can do any point. The other one, you have to have the intercept. Now, here's the sad thing. The sad hard truth, if you're trying to simplify or have the answer look like this, most of you are like, well, if it's supposed to be that, I'm going to start with that. You're not being creative. Or maybe you're just scared of distributing things. It's harder to go here and to have to plug in some arbitrary point, not knowing m and not knowing b, than going here, plugging in an m, plugging in your x1, y1, and just saying, I can distribute. I can add this to the other side. Now, some of you might need to pay attention to this little way that a seal dies. So many seals die in pre-cal. Ironically, they die in Algebra 1 and Algebra 2 and pre-cal. You would think that by pre-cal, I don't know. Why is a seal dying? Not because of plastic in the ocean, although that's a whole thing, but because there's a negative in front of the parentheses. And what is supposed to happen when you get rid of parentheses? And there's multiplication, distribution. And when you distribute, the negative should not have just gone to 1. It should have gone to. And guess where seals also die? Calculus also. Go figure. Summer review quiz that they took. Anyway, don't kill seals. Watch out for your distribution. So why am I saying that? Well, if this is such an important form, watch out for your distribution. Do it properly. Yes, it can be dangerous, but this is still easier and so much more efficient, and not just more efficient, but required once you go higher in math. So anyway, point-slope form, it's a great form. Yes, I know slope-intercept is the one that all of us, most of us, voted on. I just wanted to make a huge point of that one. You're going to have to know it. Special slopes, there are 2 of them. I guess there could be more. But basically, I'm going to talk about horizontal lines, and vertical lines, because these are the ones that we tend to get confused. Yes and no? They have to do with constants. That's very true. They have to do with constants. Horizontal line, hopefully we got that. The horizon, if you're looking out, like sitting at the beach, the horizon, horizontal. Vertical, it's the other way. Talk about a vertical drop. I'm sure there's some roller coasters, or even like the signs talking about the vertical. If you're like play volleyball, talking about your vertical, right? How high you can jump, etc. So horizontal line, vertical line. Let's talk about the M's, because the whole point are the slopes, because they're unique. The easiest way I can illustrate it. If you're skiing on a piece of land or whatever, that's horizontal. Whew. If you're skiing on something that's horizontal, how's that slope? Right? You don't got anything. Now, good thing is you're not going uphill, but you're also not going downhill. Like you can't even like turn around and you still just got it, right? If it's horizontal, what slope do you have? None. There's no inclination whatsoever, right? So your slope, none, is 0. You got nothing. There's no slope. Sorry. Now, try skiing that one. Woohoo! Death. Okay, so this one, the slope is 0. That one, you're going to be undefined real soon. Okay? Let's say you have a parachute. So if it's a horizontal line, y is not y. M equals 0. If it's a vertical line, m equals I know it got stuck. Undefined. Ran out of room. And maybe, just maybe, these can help you with what the equations of these lines can be. Because this is what kids get most confused on. Yes, the slopes, but also the equations. If m is equal to 0, go to the one you're used to. That's OK. Plug in 0. What happens if y equals 0x plus anything? The x goes away, and you just have y equaling. So yes, y does equal b, or you could say a constant, right? But we'll say y equals b. Y is going to equal the intercept, whatever it is, but y is just going to equal a number for you guys looking at it. Vertical line, well, I can't really say y equals undefined. That doesn't really make sense. So instead of being a y equals, it's going to be an x equals. So in order to get the 0 slope, you can plug in 0. It's y equals a number. So then vertical must be the other one. If you can just get the slope straight, man, everything else will work out. Last but not least, equation for slope. Slope being m, right? 3 different ways of talking about m. One could use words, rise over run. How much does a point, or I should say a line, rise and then run to get to a new point? Rise over run. You could also use some snazzy like delta notation, delta y over delta x. Delta just means change in this context, change in y over change in x. But what you guys are most used to, I would think, is the actual finding of delta y and the finding of delta x, which would be y minus over. Okay, so now that we have all this foundational stuff to lines, and 5 minutes left, we have to talk about one more special thing that will come up. Not just how to make a single line, but how to make a line based on another line. And usually if you're making a line based on its relationship with another line, you're talking about 2 things, either parallel or perpendicular. If they've given you a line, but it's not the one they want, they just want you to use it, well, they're almost always saying something to the effect of make it parallel or make it perpendicular. Parallel. Same. Just gave it away. La 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 la. Parallel. In geometry, 2 lines that never intersect. Why did I just give it away? If I just said same, what do I mean? Same direction. That's true. Maybe I didn't give it away. Same slope. Same slope. Almost always different location. If it's same slope, same location, well, it's just the same line. If it's a different location, you just keep sliding. This recording might be interesting. Okay. Same slope. Usually different location. 2 lines that never intersect. Ooh, but geometry. These lines never intersect. What are these ones called? They're not in the same plane, like parallel lines. What are these ones?
Oh, I know. Wait.
Starts with an S.
I know.
S-K. Skew. There you go. We were working. We were building up to it. Skew lines. S-K-E-W. Skew lines. Anyway, those don't intersect either, but parallel, same plane, same slope. Perpendicular. Good. They hit at 90 degrees. They form a right angle wherever they hit, wherever they intersect each other. You could like do the whole line going through. I didn't really do that. Sorry. Pretend that's a line. Anyway, opposite reciprocal. 2 things to remember. Opposite, I'm talking about the sign. And reciprocal, I'm talking about flipping the actual value itself. 2 becomes 1/2, 5 halves becomes 2/5, 1/3 becomes 3. You have to do two things. Not only flip the sign, see, that's where it becomes a struggle. So opposite, the sign changes, and reciprocal, you flip. So here's the dealio. If you have an example like number 4, and this is our last thing for today, and the end of section 1.3, which is why homework is due on Monday, on lines. What do you see that they've given you? A point and another line. They gave us a line and a point. That's, parallel perpendicular. So for both of these, for both A and B, remember what form I said was good? We're going to use the exact same form. We're going to have to do some simplifying. But the nice thing is we already have it halfway done because we already have the point. We just need the slope. So to both of them, we can say x minus the x value, x1, y minus the y value, minus a negative is plus. X minus the x value, y minus the negative, which is plus. Here's the dealio, though. How do I find the m? Same slope, opposite reciprocal if I don't even have m. Standard form. Put it in slope-intercept form, which means get y by itself. Quick mental math, but subtracting the 2x, dividing by a negative 3, you'll have 2/3. 5 divided by negative 3 is negative 5/3. Maybe this is something where you come back and see if you can make this match on your own before homework problems. But the m of this one is 2/3. Help me just finish off real fast. What do I do for parallel? Keep it the distribute, get y by itself. This one, negative 3/2. Change the sign and flip. Bye, cool kids. Your calculator quizzes. Hold on, pause. No, we'll talk about it Monday. Corrections will be due next week. If you want to see your calculator quizzes, you can come by after school. Bye, guys.